Hi guys, welcome to chapter 5. It's your polynomial chapter. So we just ended chapter 4, which dealt with quadratics. So now we're getting into higher degrees. So first things first, we're going to learn about exponents, or really we should be reviewing exponents and their rules, just the basic ones. And then we're going to use this information in order to be able to do the rest of the chapter. So as a review, let's review what negative exponents are. And not to confuse with, by the way, we should have this down at this point. Negative numbers, for example, raised to a power, just before we start this actual lesson, make sure we, at this point, definitely know the difference between these two. So a negative without parentheses stays as a negative. Okay, and then if it has a parentheses, then we make it into a positive. So I like to have parentheses and positive, double P's, think of it like that. And then the negative 5 squared would stay as negative. So that should be reviewed definitely, as well as negative exponent. So this is not to confuse with that. So to get rid of a negative exponent, you need to move it. And again, remember the rule, we did this at the beginning of the year with course readiness. If you move it, you lose it. That's how you lose the negative exponent. You will never give me an answer with a negative exponent. That's not simplified enough. So for example here, 5 to the negative second power, that just moves it to the bottom. And all you have to do now is just simplify. 1 over 25 is your answer. Number 2, the only thing you guys tend to do here is you only like to apply the exponent to the top number. Make sure you apply the negative exponent to both the numbers here. So really this just means we're going to flip the fraction and raise it to the power of 2. And again, that 2 needs to be applied to both numbers. So 8 squared is 64, 3 squared is 9, and that would be your final answer. And then just a reminder, when we're doing these as they get more complicated, the negative exponent only applies to the number it's attached to unless it's in parentheses. So for example, if it was in parentheses like this, the negative 4 would be applied to both 6 and the variable p, but since it's not have parentheses, the negative 4 only applies to variable p. So the 6 is going to stay on top, and then p to the 4th goes to the denominator. Okay, so those are just negative exponents. Now we're going to review exponent rules. Okay, and then again, I went over this in course readiness. Kind of think of it, or the way I teach it when I did Algebra 1, is teach it like a PEMDAS rule. So you write PEMDAS vertically like this, and then we have 3 rules. We have our power rule. So I'm going to go like this. I'm just going to give you an example. Power. So we have x squared to the 3rd power. Okay, and you're like, I don't know what to do with that. Okay, so this has an exponent. So if you don't know what to do, if you forget at some point, you're going to look down the PEMDAS line, and the M stands for multiply. So I'm going to multiply those two numbers, 2 and 3, to get x to the 6th power. Okay, similarly, we will have our multiplication or our product rule. And if we're multiplying two exponents together, x squared times x to the 3rd, then again, we look down in our PEMDAS, and what we're going to do, that means we're going to add those two numbers together. So 2 and 3 together makes x to the 5th. These 2 rules are the ones you guys get confused the most. So please, whatever you need to do to memorize the difference between these, please do that, because that's where I would say most of your sloppy mistakes happen between these 2 rules. So it's an exponent. We are multiplying those 2 numbers. If they're being multiplied together, then we add those 2 numbers. And the one you guys are pretty good at is your division rule. So if we are just dividing, this is called your quotient rule, then we look down and we're going to subtract those 2 numbers. So 5 minus 3 is 2. But like I said, that one you guys are pretty good at. It's the ones on the left-hand side that you guys confuse a lot. So please know the difference. Okay, so we're going to start off pretty easy. Obviously, number 1 would be easy, and then as we start getting into the higher numbers, it's going to get a little bit harder than what you would typically see on a quiz or test. All right, so when we're multiplying a bunch of numbers in exponents, just make sure you guys are doing it by common terms. So for example, we're going to multiply all the numbers together first, or the coefficients. So 2 times 3 times 4 is 24. Now let's get our like terms. So we have y and y to the 5th. These are being multiplied. So what do we do with those two numbers, 1 and 5? We add them together to get 6. Same with w squared times w to the 5th. Add those two numbers together, so w to the 7th. So you see how a very sloppy mistake would be to do like 2 times 5, which would be 10. So very careless, small errors could happen, but it's going to really affect the rest of the problem. Number 2, so a lot more numbers going on here, and now we're involving negative exponents. So let's go slowly here. So we have 2 times 4 times 7, which is 56. Now let's do the u's, u and u over here. And again, with those numbers, they're being multiplied, which means we're adding them together. -6 plus -4 is -10. And again, that means we're going to have to do something extra. We'll do that the next step, but let's keep it for right now. Now we'll deal with the x's, x to the 6th and x to the -6. We add those together. 6 minus 6 is 0. And then, oops, I already used green. So we'll do v -5 and v to the invisible 1. We add those together to get v to the -4. Okay, and then we would never leave our answer like this. You'd be marked wrong because it is not simplified. So we're going to keep everything positive upstairs. So 56. U to the -10 belongs on the bottom, as well as v to the 4th belongs on the bottom now. And then x to the 0, remember anything to the power of 0 is 1, so it just kind of disappears from there. So that would be your final answer. One quick thing I want to say about negative exponents before I forget is that there is something, the big mistake people think about. So let's pretend, for example, this was a -2 in the front. So then like obviously it'd be -56. You guys associate so much negative numbers being on the bottom that you guys would have moved this 56 to the bottom, which is false. Only negative exponents go to the bottom, not negative numbers. So for example, let me give you one. -5 squared. Okay, that doesn't go, nothing goes on the bottom there. 5 to the negative squared, that's when you move things to the bottom. So big difference there. A lot of you guys assume this means the same thing as doing that. Okay, which it's not. So only negative exponents go to the bottom, not negative numbers. Okay? So make that difference. Again, very small differences, but they do make a big deal mathematically. Okay, so this is just your basic division one. I like to divide if there's like, so for the A's, for example, just do 3 minus 4, which is -1. So you know that A belongs on the bottom, or I know the most basic way to think about this is that you subtract these two numbers and wherever the biggest one is, which is 4, that's where you put the answer. Okay, and then same thing for above. 5 minus 2 is 3. And there it goes. And then just be careful when we have negative exponents and numbers. There's different ways you could have done this problem, but I'll show you 2 ways. So you can move the exponent first to make it positive. So now you could have x to the 5th and x to the 7th next to each other. We know we're going to add those two numbers to get x to the 12th. A different way would have been to just use your division rule, which would be you subtract from top to bottom. So 5 minus 7 is equal to 12. So that means the answer would be x to the 12th. So both by using the negative exponent rule and the division rule, Either way, you would get the same answer. So again, just knowing the rules accurately can help you with most of these problems. All right, now we're into our power rule. Again, making sure if it's in parentheses, the exponent applies to everything in the parentheses. So not just the n, which a lot of people want to do, it also applies to the 3 as well. So 3 squared is 9, and then n squared. Okay, number 6. Again, this 4 applies to -3, x to the third, and z squared. And like I told you at the beginning of the year, whenever we're evaluating for a number, please leave it in parentheses so we get our negative signs correct. So this is -3 to the fourth, and we will simplify that in a sec. Now with the exponents is x to the third and x to the power of x to the fourth. We are now multiplying those numbers, not adding them. Same with z, so z to the 8th. And the only thing here now we need to simplify is a -3 to the fourth. So -3 multiplied 4 times is 81. And then x to the 12th, z to the 8th. Now number 7. Okay, again, that 3 exponent applies to the -3, to the z, as well as the y. And this is a case, again, where I said, like, the -3, you guys assume just going to move to the bottom because it's a negative number. It's not a negative exponent, so it's going to stay on top. So make sure you clarify that. So it's -3 cubed. Z to the 4th becomes z to the 12th because it gets multiplied, all over y to the 3rd. And then -3 cubed is -27, z to the 12th, all over y to the 3rd. And again, this stays where it's at. Do not move the -27 to the bottom because it's a negative number. Negative numbers are okay. Negative exponents are not okay. So that is a perfectly fine answer. So pause here and try number 8 all by yourself, and then come back for your final answer. All right, number 8. Not only had you do the power rule at first, but then you also had to do the multiplication rule to combine these at the end. Okay, so make sure that this accurately was 4 at the beginning because it's -2 squared, and this was -27 because it was -3 cubed. So hopefully you got to the second step first, and then remember that these are being multiplied, and so you just multiply everything out after that. So it was a -108 because you did 4 times -27, and then x to the 4th stayed because it didn't have any other friends. All you had to do at this step was do y squared and y to the 9th become y to the 11th, and then the z just dropped down as well. All right, so those are your exponent rules. Now we're kind of going to warm up for the rest of the chapter by teaching you guys how to multiply monomials and binomials, and then polynomials. So this is kind of what you guys already know how to do, and I'm going to show you guys a pretty easy way to do it at the end as well. So all we're going to be doing here is distribution. So we're just going to distribute 4b to the 5th times c to 3 different terms. Okay, and that is making you and testing you on your exponent rules and just being very careful. So first we're going to multiply 4b to the 5th, c times 3b squared. So that would get you 12b to the 7th times c. Okay, then you move on to now multiplying the first term times a 5b cubed c to the 6th. And we would get 20b to the 8th, c to the 7th. And then you do the last terms together. So it would be -28 b to the 5th, c to the 7th. And the only way we'd be able to combine these any further is if they were like terms. Remember when you add like a bunch of x's together or y's together when it was in Algebra 1? Now these variables would have to be exactly the same in order to add any of them. So none of them are exactly the same. They're all very different. So then you cannot combine them. So you leave your answer as is. Okay, same idea with number 2. This is just a distribution problem. So we're going to distribute this this outside number to, again, all 3 terms. So my first terms together would be negative 24, x to the 5th, y to the 10th. And now we do it times 8x, and you'd get negative 32, x to the 6th, y to the 6th. And then to the back number, negative 5 would just be plus 20, x to the 5th, y to the 6th. And again, that's as far as we can go because none of the variables are exactly the same. So you would just have to leave it like that. Okay, so these were monomials, because again, monomial meaning mono, meaning one term. Now, so 1 and 2 were both monomials. This was a monomial, this was a monomial. Now, number 3 is a binomial, 2 times a trinomial, 3. So different ways you guys can do this. You can just do distribution. So you would do 5u times 6u and negative 4x and 5. And then you would take 7x and do the exact same thing. Okay, because there's no foiling here. We only do FOIL with binomial times binomial. So there's no like FOIL there. The easiest way I like to do this is I like to create a box. And I know some of you guys were taught the box method when you learned how to FOIL. So keep on using that and you're going to be really good at this. And then I'll intro this to you guys for 2 reasons. One reason is that it keeps your work super nice and neat, because if you had to do the whole distribution 6 times, like I said, your work gets super long, like super long like this, and it's hard to keep track of everything. So this nice little box just keeps it in one little area. And then second of all, the reason I'm really showing you guys this is that we're going to learn how to divide polynomials in the next section, and it's a very difficult concept, and I actually use a box to teach you guys. So it's very similar in the way we're thinking right now. So if we start thinking about it today with multiplying, hopefully it transfers over easier to you guys when we learn how to divide. So what you do is that you can see when I was talking, all I did was create a box, and you create a box in the size of your binomial. So 2 boxes and then 3 boxes. And then you, like a Punnett square you learned in science, you just put the expressions on the outside of the box. And how you get the inside the box, probably people you're already guessing, is that you just multiply. So the top left box here is just multiplying 5u and 6u together. Okay, so this would be 30u squared. Underneath it, you would get 42ux. And then we'd keep on going. And then the last column, we would get 25u and 35x. So this problem itself had 2 variables. Usually when you just have one variable, some really nice, interesting things going to happen, but it also happens nicely here. So the reason I like the box a lot, and we're going to use this concept a lot in division, is because of this right here. Your diagonals should typically be common terms. That way you can add them right here before you write your final problem. So as you can see here, just because we have a bunch of different variables going on, these aren't common terms, and that's okay. When we get farther into the chapter, will always be common terms, but for right now, it's okay if those are not. So all you're going to do, your answer to this problem is all these boxes. So it's 30u squared, which is that top box. If we have common terms, let's just add those together. So you have 42ux and negative 20ux. Together, that makes 22ux. And since there's no other common terms, all you're going to do is just list the rest of these terms, and that would be your final answer. And since I was such a stickler up until now with standard form, please stick with that. But when there's multiple variables going on, there's really no standard form that I'm going to be harsh on, because I didn't even follow anything on this, obviously. So just put all the terms together. We would never mark you guys wrong if there was anything as out of order. So this is totally fine. Again, if you had stuff swapped, if you had like the 35x over here instead, totally fine. As long as you have these terms, then you're correct. All right, number 4, we got even a bigger box to deal with. So we have again, let's get the vocab correctly, a trinomial 3 and a trinomial. So we make a 3x3 box. And so it's going to be a square, more of a square, so I'm stretching it a little bit. And then you just put one of them, again, it doesn't matter. I just usually like to take the first one and put it down the left side. But if you wanted to put that across the top, you would get the same answer. So it doesn't really matter where you put these. And then I'll put the second part on the top. And then we now multiply to get the inside. So 42x squared. And then I just like to go down. Oops, and that's negative e. Very careful there. Negative 42ux, and then negative 6x. This would be 42ux. And the last column is 14x, negative 8u, and negative 2. All right, so like I said, before you write down your answer is really all of this. So you would just write this out, and then that would be it, and you combine like terms. But try to utilize a box to itself. Any of your like terms would be on a diagonal. So negative 42ux plus 42ux, obviously that cancels out, so there'll be no more ux's. Except I did math wrong. I knew that looked wrong when I first did it. Hopefully you guys caught my mistake. Boop, 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 boop. Negative 24ux. It's a little bit of dyslexia there. All right, so there you go. So negative 24 and 42ux. Now let's see if there's anything on the other second diagonal. We have negative 6x and 14x. Okay, so those can be combined in our head. And then lastly, we have negative 6u and negative 8u. All right, so let's write down everything. So I'm going to start at the very top left, so 42x squared. Now we're going to add our combined terms, so negative 24ux and plus 42ux would be 18ux. Let's do our second round, so negative 6x and 14x makes 8x. I'll do our last combined term, so negative 6u and negative 8u makes negative 14u. And then I'm just going to copy down our lonely pairs that didn't match up with anybody, but they are still part of the answer. And like I said, this is a random order I put down. If you wanted to put it in any other random order, you still would be accurate. As long as the terms and the signs and the exponents are all correct, then you will be correct. All right, so pause here, try the next one all by yourself, and then return back for your answer. All right, here's your final answer. So again, it could be in any other order than what I have down here, but you need to make sure all your terms are there and that all your exponents are the same. So right now we have 1, 2, 3, 4, 5, 6. So I should have 6 terms in total in any other order than this. So that was practicing multiplying polynomials. Now we're going to relearn how to divide or simplify exponents as well. So up until now, I think a lot of you guys have wanted to simplify your fractions, and I've told you we're going to learn it at some point, and then today is the day. So recall when dividing exponents, you subtract the numbers. You guys know that. I'm going to talk about something called sharing the love and how you're going to simplify or separate these into multiple fractions. You'll see on either your test or Alex that some of these problems in this chapter are going to want you guys to not keep your answer like this. This is not simplified enough in some areas. We're going to want you to separate them into multiple fractions. All right, so what I like to do here is something called, like I said, share the love. What you're going to do is basically create a heart like this, see, with your fraction. So what I like to do is that you're going to simplify this as a fraction. So 2v to the 5th over v squared. 2 would stay on top. And then v to the 5th divided by v squared is v cubed. Okay, now we're going to do the same thing and make a heart on this side. Okay, and now we're going to simplify that. So plus 9, and then v cubed divided by v squared is just v. So that's why I said it's called share the love. It's like a heart. So when you hear me say that a lot to you guys, that's what I mean. Okay, so that's your final answer because these cannot be combined. Number 2. Okay, so now you have coefficients in the front, so we're going to share the love. So we're going to do this as a fraction. So 6 divided by 3 is 2. And then the exponents become z cubed. And then this part of the fraction is a -4. And then just z. Now number 3. We are going to do this one first. So 2 divided by -1. All I'm going to do is just bring that negative to the top. And then x to the 4th divided by x squared is just x squared. And I'll do the same thing over here. I'm just going to make this a -6 instead. And then it's going to be x. Number 4, the reason I wanted to show you this one is because you guys easily get confused in math sometimes. But all so far we've been writing it as fractions to start with. And then this one just has divided by 2x. Please understand this is the exact same thing we've been doing. Okay, you can say divided by 2x like this horizontally, or we just can keep on doing it the way we've been doing it and just say divide by 2x like this. And it means the exact same thing. So please don't get thrown off by like the little tiny things that we can change a problem with. Okay, so now we're going to do 4x to the 4th divided by 2x. So 2x to the 3rd. Now we're going to do the middle term. So just add a different term. So 12x cubed and 2x. This becomes 6x squared. And then lastly, you have 6 over 2x. So 6 divided by 2 is 3. And then that x can't really go anywhere. It needs to stay on the bottom like that. Okay, number 5, before I let you guys do one by yourself. So now we're into the big boy. So you have negative numbers to deal with. You have bigger terms and expressions to deal with. And there's 3 of them. So just go slowly, because you guys know what you're doing here. Just please go slowly and take account of negative numbers and everything. Okay, so first we have the -12v squared, and then the one on the bottom. So just take this as a simple fraction. So -12 divided by -2 is 6. We deal with the v's, v to the 7th and v to the 5th becomes v squared. And then with the z's, you have 2 and 4, and 4 is obviously bigger, so I'm going to put 4 minus 2 on the bottom. Okay, done with that. Now let's do the middle term. So we're just going to divide these like normal. So you're just basically separating these into 3 different problems, or like mini problems for one. So think of it more like that, and it becomes a lot easier. So this becomes +3. With the v's, it comes v squared, and then the z's just becomes z on top. Okay, and then lastly, you have your last terms. Okay, so 11 and 2 do not go into each other, and that's totally fine. So we're just going to keep them as 11 and 2. We just more of the time in math, we like to keep our negative numbers on top. So that's really the only thing to change here. So it's going to be a negative 11 all over 2. With the V's on this one, 4 minus 5 will go on the bottom. And then Z will stay on top. And that would be my final answer. So try number 6 all by yourself and then return back for the answer. All right, number 6. It was just 2 terms, but just be very careful with signs and fractions, and this will be your final. So again, this should have just been a review of multiplying exponents and dividing them and simplifying, and then we're going to really get into the chapter with the next section.